Today we're going to review material for the last exam, Exam 9, on Chapter 18. But before we do, I've come across the final exam schedule, and assuming nobody wants to come and take the exam in person, the exams during final week that are administered through Brightspace must be completed by midnight on Wednesday, May 10th. So that's your deadline. If you want to come in person, then let's see, this is a 9 o'clock class on Tuesdays and Thursdays. The exam, according to the schedule, the exam is on Thursday, May 11th at 8 o'clock. But unless you have a conflict, or and if you want to come in person, then let me know. And if you have a conflict, we'll, with class time, take the exam during the regular class time, which is where I prefer. If that's a problem, if it's a conflict with another course, then let me know, and I'll be here at 8 instead. Otherwise, if you want to come in person, come during the regular class time on Tuesday, May 9th. And if you want to take it online, then your deadline is Wednesday at midnight. All right. So now, let's take a look at Chapter 18, review. All right, and I've shared the document, and I picked out some sample problems to use, except where did the highlights go? Okay, something's wrong with this document. I'm going to have to unshare and start over again. Okay, let me go look at that document and be sure it's still loaded properly. No, it's not. Okay, give me a second. I'll close that one and reopen it. Okay. CHEM100, Exam 9, and review key. Here we go. That's better. Okay, let's change to a different zoom. Go. And then I'm going to share the document. Okay, I think we're good. Now we can get on with business. Oxidation reduction reactions and electrochemistry. Number 1. Consider the following reaction, where we have barium plus chlorine yields barium chloride. Okay? Which of the following statements is true? Well, since we know it's going to be about oxidation reduction, let's assess this reaction based on the rules that we've learned for oxidation states. That one's 0, that one's 0. Chlorine would be a -1. And barium, or we could go the other way. Barium is an alkaline earth, so it has to be a 2+. And that, of course, makes chlorine a -1. Now, what happened? Well, barium had to lose 2 electrons per barium. Times 1 barium equals 2 electrons total. Chlorine, on the other hand, gained 1 electron per chlorine times 2 chlorines equals 2 electrons. Okay, so now we can answer the question. Which of the following is true? The barium atom is losing electrons. That's true. Therefore, it is oxidized. Right? Remember oil rig? Oxidation is loss. So this is true. It is oxidized. Now let's see if we have any others in there. Okay. E says none of these. We found one that is true. That must be the only one that's true. We could look at the rest of them, but in the interest of time, and if you're taking an exam under these circumstances, you work down until you find the right answer and you're done. So let's move on to number 2. Number 2, I'm gonna scroll just a little bit. Maybe we get 2 and 3. Here we go. In the reaction, 2 calcium and oxygen yields 2 calcium oxide. 2 calciums plus an oxygen yields 2 calcium oxide. Okay. The calcium is what? Well, we do our assessment again. 0, 0. Calcium is an alkaline earth. 2+. 2 minuses for oxygen. And the equation is balanced. So, what happens to calcium? Well, calcium went from a 0 to a +2. So it lost 2 electrons per calcium. Right, so that means it was oxidized. All right. And it looks like A is a correct answer. All right. That was simple enough. Let's move on to number 3. In the reaction, strontium plus fluorine yields strontium fluoride. Should be 2 here. There we go. And that one's balanced. The fluorine is what? Well, we do our assessment. Strontium is an alkaline earth, so it's a 2+. Fluorine is always a 1-. So we went from fluorine to fluoride. That means it gained 1 electron for each fluorine. Okay, so what happened to it? A gain of electrons is reduction. So that fluorine was reduced. And that means A is our answer. All right, scroll a little bit more. Pick up 4 and 5. The oxidation state of sulfur in K2SO3. There we go. So what do our rules say? Our rules say that alkaline metals are always a +1. Oxygen is a 2-. So 3 times 2- is 6-, and 2 times 1+ is 2+. So these together make -4, correct? Okay, that means this sulfur has to be a +4. And that's A. Gives us A as the answer. Number 5. The oxidation state of chlorine in lithium chloride. Okay. Well, we know that lithium, being an alkali metal, has to be a +1. So chlorine has to be a -1. It's just that simple. Answer to that one is A. Let's see, we got 6 and 7. All right. Those previous examples were ionic compounds. In other words, the oxidation state and the charge on the ion are identical. Now we have a problem with a covalent compound. In this case, you don't have ions, but you do have oxidation states as assigned. Oxygen's -2, right? 2 times -2 is 4-. It's a neutral compound, so that means this carbon has to be 4 pluses. Okay, so that makes A the answer. While we're here, 7. Oxidation state of sulfate of sulfur in sulfate. Right? Remember, the total of all the oxidation states of the elements in a compound or a polyatomic ion must be equal to the charge. So for this one, the charge was 0. So they had to add up to 0. This one, the charge is 2 minuses. So everything has to add up so that you have a 2- charge left over. And remember, here's how we do that. Oxygen is a -2. 4 times that is 8. But we're going to hold 2 of them out for that negative, those 2 negatives. That means we only have to balance this 6-. So sulfur is 6+, which is also A. Okay. All right. Number 9. H2CO3. If we were naming this and if it were in an aqueous solution, what would it be called? Well, it's got hydrogen there, so it's an acid. It also has an oxygen, so we don't start the name with hydro. We look at this part right here. Carbonate. H become X. So it's carbonic acid. Now, that wasn't a question, but it's useful to refresh our memories. What's the oxidation state of carbon here? All right, carbon. Remember, hydrogen is +1. Oxygen is -2. So 3 times -2 is -6. And 2 is +2. Put them together, you get -4. That means this carbon, there's only one of them. So we have to have a +4 for that carbon. And that would be A again. About 10. The oxidation state of chlorine in this ion. That's a polyatomic ion. Remember what that one is. That's hypochlorite. Oxygen's -2. Only one of them. But we need to keep one of these out. So you really only have to balance a -1. That means a +1 here. And check that out. +1 and -2 is a -1. So +1 for chlorine is D. All right, that was 10. Scroll a little bit to catch 11. 11. The oxidation state of Rb, rubidium, in any compound. Right? So what would be the oxidation state for rubidium if it were in a compound? Well, look at the periodic table. Where is it located? Rubidium is an alkali metal. That means when it's in a compound, it usually has a charge of +1. Rubidium is going to be in ionic compounds. I can't think of a single one where it would be in a covalent compound. So B is the answer. +1. All right. Let's get number 12. The oxidation state. This is kind of a trick question. What's the oxidation state of oxygen in that diatomic molecule? It's the standard state of oxygen as an element, so its oxidation state is 0. All right? C is the answer. How about, let's see, better do that. Oxidation state of phosphorus in magnesium phosphate. Let's see, 15. Magnesium phosphate. Okay. We can do this 2 ways. We can do the entire compound, or we can take the polyatomic ion right here and treat it separately. Right? If we do the whole thing together, then we have oxygen is a -2. How many oxygens do we have? We actually have 8. 2 times 4 is 8. So 8 times -2 is -16. Then magnesium is an alkaline earth. It's always +2. But we have +6 there, 3 of them. Right? Combine these, we have a -10 that has to be balanced in a neutral compound with 2 phosphoruses, right? 2 of them. That means we balance the -5 as a plus. So each one of these phosphoruses must be a +5. And that's the D answer. Okay, 15. How about scrolling again? 17. Dichromate. That's a polyatomic ion. We need to come up with oxidation states that will give us a total of -2. So -2 for oxygen, -14 total, but we need 2 of these negatives held out for the charge. So -12 means that we have to balance with +12 over here, but there are 2 of them. So each one is a +6. And that's B is the answer. Right. Scroll a little bit more. Lots of practice problems there. Let's go to 20. Let's see. 28. Okay. In reacting, metal atoms characteristically do what? Metal atoms tend to lose electrons in reactions. So this metal would yield something over here with a charge +1, let's for argument's sake, +1, it would lose an electron. So that means metals usually are oxidized. They lose electrons. That means it becomes a cation. All right, so A is not right. B is correct. Loses electrons. But notice E is 2 of the above. So we got to look at all of them to see if there's another one that's right. Decrease in oxidation state. Is this a decrease? No, it's more positive. That's an increase. So the oxidation state increases for metals. Form covalent bonds? No, they don't. Metals form ionic bonds. So there's only one correct one there, and that's B. Loses electrons. All right, 28 to 29. Which statement is true of the following reaction? All right, 2 potassium, copper 2 chloride, potassium chloride, and copper. Okay, it looks like they're asking for oxidation reduction. So let's go ahead and assess this. 0 for that one, 0 for this one. Chlorine would be a -1 here. That means 2 minuses total. This is a 2 plus. This is a -1. This is a +1. It's an alkali metal. So now we can assess what happened. Right? Potassium did what? It's a metal, so it lost electrons. 1 electron per potassium. Chlorine didn't change. Copper did change. Copper went from +2. Actually, copper gained electrons. Right? Gained 2 electrons per copper. This is times 2 equals 2 electrons. So we're balanced. Right? We said that metals tend to lose electrons unless they're reacting with another metal. And in some cases, one of the metals loses electrons and the other metal gains electrons. So that's what happened in this case. So what happened to copper? Well, it was reduced. It gained electrons. Okay, so we found our answer. A is the answer. All right. Let's scroll again. 30. In which of the following does nitrogen have an oxidation state of +4? Okay, so in this case, we've got to do each one to find out which one has an oxidation state of +4. So we've got HNO3, NO2, N2O, NH4Cl, and NaNO2. Okay, since we've got unique answers for A through E, test taking technique, we can start from the top, work our way down. When we find the right answer, we can stop. Once we find one with a +4 oxidation state, we need a +4 in somewhere in here. All right. Hydrogen is a +1. Oxygen is -2, so that's a -6, and a +1 yields what? -5. So this must be a +5, right? A is not it. We have -2 here, -4 total, +4. That's it right there. B is the answer. We could do the rest of them, but in the interest of time, we're going to dispense with that. Plus, the review document has a complete discussion of this problem anyway. So if you want to look at the others, then you have the review document to help you through that one. All right, answer the question refers to following reaction. Titanium 4 chloride. Titanium 4 chloride. And that's a liquid. How about that? Oxygen gas yields what? Titanium titanium 4 oxide plus 2Cl2. Yes. This is solid, this is a solid. Okay. Which species is the reducing agent? Remember, the reducing agent is oxidized. So which one was oxidized? Well, let's see. Chlorine would be -1. So that means -4 total plus 4 here. Oxygen 0. Oxygen here is 2 minus, which means -4 plus 4 again. So nothing happened to titanium. But chlorine is 0. All right. So we're looking for the one that's oxidized. Which one lost electrons? Which one increased its oxidation number? Well, chlorine is a minus here, and it went to a 0 there. That means a loss of 1 electron per chlorine. Okay. So there it is. The chlorine in titanium 4 chloride is the reducing agent. So the best answer for that one is D. Okay. Takes care of 34. Who's next? 38 and 39. 38. In the reaction, P4 plus 10 Cl2, and we get 4 PCl5. Okay. Phosphorus is what? Reduced, oxidized, whatever. Well, phosphorus is 0. Chlorine 0. Over here, we have to decide which one are we going to fix. And remember, the one to the right on the periodic table, the one to the right is the one we give a fixed charge, and chlorine is a halogen. So we're going to give it a -1 oxidation state. Right? That means +5 for that phosphorus. All right, so what happened to phosphorus? All right, isn't that the question? Phosphorus is what? It went from a 0 to a +5. There was a loss of 5 electrons per phosphorus. Okay, so it was oxidized. Okay. 39 is based upon the same equation. So they're wanting to know now what happened to chlorine. Well, chlorine went from 0 to -1. It was a gain of 1 electron per chlorine. All right. So chlorine was reduced. Right? That's B. Okay. Takes care of that one. Let's scroll and see what's around the corner. How about 44? In the reaction, magnesium plus sulfuric acid. This is a displacement reaction. Magnesium is going to displace those hydrogens. Magnesium sulfate plus hydrogen gas. Okay. Which element is oxidized? It says if any. So are we saying that maybe it's not an oxidation reduction reaction? Okay, that's what's implied. But notice there's an element here it's in a compound over here. There's an element here, it's in a compound here. So that tells us that definitely this is a redox reaction. With 0 here, 0 there, and which element is oxidized? All right. Sulfate ion has remained intact. That means there was no change in the oxidation states of either of these elements. That means we can ignore the sulfate. It is a spectator. But hydrogen went from a +1 to a 0. Magnesium went from a 0 to a 2+. Okay. So which one's oxidized? Which one lost electrons? Well, the prime candidate for losing electrons is a metal. This is the only metal in there, and it did, in fact, lose 2 electrons per magnesium. So magnesium was the oxidized species. All right. 48. Okay, can't get both of them. We'll scroll in a second. 48. In the following reaction, which species is the reducing agent? Okay, we've got 3 coppers. We've got 6 protons, H+. We've got 2 HNO3 yields 3 copper 2+ ions plus 2 NO plus 4 water. Okay, so we're looking for the reducing agent. Reducing agent, which means whatever this is must be oxidized. Oxidized. Okay, which one was oxidized? Okay, we have to do our bookkeeping now. That's 0. That's a 2+. This one is a 1+. We have -2, -6 here, +1 there. So this together is a -5. This must be a +5. This one is -2. That makes this one a +2. That's a -2, and this is a +1. Okay, now we can see which changed. Well, copper definitely changed. Copper went from 0 to 2+. So what does that mean? It means it had to lose 2 electrons per copper. Right, well, there it is. The reducing agent is the one that was oxidized. Copper was oxidized. It lost 2 electrons. So this is the reducing agent. It causes the reduction of nitrogen. Right? Nitrogen gained 3 electrons for each nitrogen. So copper caused its reduction because it was oxidized. Okay, so the answer is B, copper. Let's see, scroll for 49. Yeah, we get it all up there. Answer the following question that refer to the unbalanced reaction shown below as it occurs in acidic solution. All right, determine the coefficient for the iodide ions. All right, we've got dichromate, and notice the spectators are left out. We've got some anions and cations that are just left out of the reaction because they don't participate in electron transfer. So this is 49. Thanks. And we're given this reaction, Cr2O7, O7 2 minus, and iodide yields Cr3 plus and iodine. Okay. This is in acidic solution. We're going to have to use the half reaction method because we have an oxygen here and there's no other oxygen anywhere. We can't use the budget method. We can't use a simplified redox where you just track the electrons. Some reactions you can do that, but not this one. We've got to determine which one is which, right? So let's do oxidation states. That one is a -1, this one's a 0, and this one is a 3 plus. So oxygen's -2 times 7 is -14. Hold two of them out for that negative. Right? That means we need a +12 here or a +6. The oxidation state with that chromium. So chromium goes from a +6 to a 3 plus. What is that? It had to gain 3 electrons. That's the reduction. So we've got this one, O7 2 minus, and it's going to go to this one. Okay. And I'm going to put the electrons in there now just so we don't miss them. We went from +6 to 3 plus. Gain 3 electrons. But there are 2 chromiums, right? So actually gain 6 electrons total. Okay, oxidation. That means iodide must have lost electrons. Right? How many did it lose? Well, it went from a -1 to a 0, so it lost 1 electron per iodine. But there are 2 iodines, right? So that means it lost 2 electrons. Okay, let's see. 2 iodines, 2 iodines, 2 chromiums, 2 chromiums, oxygens. We need 7 oxygens on this side as water. Now we have 14 hydrogens. There we go. We don't have that problem down here. Now we balance the electrons, right? 2 electrons here, 6 there. So if we multiply this one times 3, we should get 6 electrons in this half reaction. So that means this one is 6, this one is 3, and this one is 6. Okay. Now, do we need to combine them? If the question is, what's the iodide ion coefficient? We've got it right here. It's 6. There are no other iodides here to cancel, so that is the answer. 6 iodides. D is the answer. Right? And if you're middle of a test, right, you want to move as quickly as possible, that's the answer. We don't need to go any further. Unless there's another problem here that has need of that reaction. There is one there. Right? Determine the coefficient of Cr3 plus. Right? Cr3 plus is 2. Right? If that were the question, yeah, that would be right. How about this one? Determine the coefficient for water in the balanced equation. There's no waters down here. There's just water here. The answer there would be 7. Okay, so we got those 3 for the price of 1. How about this one? 52. There we go. For the reaction of sodium bromide with chlorine gas. So you got to be able to write the compounds and the elements correctly. Sodium bromide, right, +1 - 1, and chlorine gas. Cl2, that's one of those diatomics that you had to memorize at the beginning of the semester, produces sodium chloride and bromine. And bromine is another diatomic. So I wasn't joking at the beginning when I said, memorize those diatomics. You will need them. So what's the appropriate oxidation and reduction half reactions? So we want oxidation and reduction. Okay. This is a 0, that's a 0, -1 + 1, -1 + 1. Okay. So the oxidation step is the one where we lost electrons. Chlorine goes from 0 to -1. Now that's gain electrons. Bromine goes from -1 to 0. It lost an electron. Right. So we got, notice that sodium doesn't change. Sodium is a spectator. So actually, we're only interested in bromine. Yields Br2. Okay. So it's going to lose electrons, but it's going to have 2 bromines on this side and 2 on this side. So that means we lost 2 electrons. Okay. How about the chlorine? Cl2 yields what? Well, sodium's a spectator, so we only need chlorine -1. We need 2 of them. So how many electrons did it gain? It went from 0 to -1. So it gained 1 electron for each chlorine, but we have 2 of them. Okay, so there are our reactions. They cannot be simplified any further. So where's the oxidation one with 2 bromides? Well, B has 2 bromides, just like that. Is the reduction correct? Cl2, 2 electrons? Yes. B is our answer. All right. Scroll a little bit more. Okay. When the following reaction is balanced in acidic solution, what is the coefficient of water? All right. So this is the given reaction. 56 is it? Is zinc plus nitrate yields Zn2 plus and ammonium. Okay. So this one is 0 oxidation state. That one's a 2 plus. This is 4 plus for the hydrogens, right? Plus 1 times 4. We need to hold one of these out. Right, so it'd be only 3 plus that we need to balance. That means 3 minus for that nitrogen. How about these? All right, -2, -6 total. Hold one out, plus 5. So now we can assess which one is the oxidation state and which one's the reduction. Oxidation. Which one lost electrons? Well, it looks like zinc went from 0 to 2 plus. It lost 2 electrons. So zinc yields Zn2 plus, and it lost 2 electrons for each zinc, and there's only 1 of them. Then we have nitrate. It went from a plus 5 to a 3 minus. Right? If this one's 3 minus and this one is 5 plus, how many electrons did it have to gain? Well, it gained 5 electrons to go to 0, but it gained 3 more. So 5 plus 3 is 8. It had to gain 8 electrons for each nitrogen. All right. So we got 1 zinc, 1 zinc, 1 nitrogen, 1 nitrogen. We need to balance the oxygens. So we have 3 plus 3 waters. How many hydrogens go on this side? Well, notice we've got more than one location for the hydrogens. We've got 6 hydrogens here, but we've also got 4 there. 6 plus 4 is 10. So we actually need 10 hydrogens on this side. Okay? So now we can balance the electrons. The electrons, we have 8 electrons here, we need 8 here. So if we multiply this by 4, that gives us 4 there, and 8 here. Okay? So now the electrons are balanced. What's the coefficient of water? Well, where do we have waters? We only have waters here, nowhere else. So the coefficient of water is 3. That makes C the answer. Okay? Let's see, are we going to need that one again? I don't think so. Okay. So we can erase this, go to the next one. Uh, 58. Which of the following is true for a galvanic cell based on the following reaction? Okay. Zinc plus copper yields Zn2 plus copper. All right. So zinc is being reduced. Okay, let's assess. There we go. So zinc is doing what? Zinc is being oxidized. It's lost 2 electrons per zinc. Copper is being reduced. It's gained 2 electrons per copper. Okay? So let's look at them one at a time. The zinc is being reduced. Is the zinc being reduced? No. Zinc is being oxidized. So A is wrong. How about B? The zinc serves as an anode. Is it an anode? What happens at the anode? Oxidation happens at the anode. Right? Oxidation. That's true. B is true. Zinc is at the anode. How about copper 2 plus? Copper 2 plus is being reduced. Yes. It's gained electrons. It's being reduced. How about D? The copper serves as the anode. Well, you can't have it both ways. Copper is actually the cathode, the site of reduction. Right? So D is wrong. E says 2 of the above. Right? So that's your answer. E. Right. 58. Let's see, 60 and 61. 60. All right. In a car battery, which of the following is the electrolyte? Right. The electrolyte is the solution in which the electrodes are immersed. Right. We studied that 2 days ago. The electrolyte for the car battery, the lead acid battery, is sulfuric acid. That's the electrolyte. Okay. 61. In a lead storage battery, PbO2 is found at what? PbO2. What is the product? Right. When we combine this with H2SO4, what do we get? Well, we get lead sulfate. Or we get only one of them. This is a +4. This is a +2. So lead in this case is being reduced. It's at the cathode. Right? So this is the cathode. While we're at it, what's the anode? The anode is lead. Yields the same product. It went from a 0 to +2. That means it was oxidized. But the answer is cathode. This is the anode. That's the cathode because it's being reduced. All right, 61, 63. When a metal corrodes, what's happening chemically? When a metal corrodes, there you have a metal, and it makes a metal with some charge. It's always positive. And it's combined with something, usually either oxygen or sulfur. When it corrodes, it has to lose electrons. Okay? So if it's going to lose electrons, the metal atom loses electrons. A is the answer, right? E says none of these, and we already found one that's right. So A is your answer. Right. 66. Balance the following redox equation in acidic solution. What's the coefficient for water? All right. We can do that. What's our starting reaction? CH3OH. That's methanol, wood alcohol. That's the one you don't drink. You drink that one and you'll go blind. Cr2O7. All right. And then we have CH2O, which is, let's see, that's an aldehyde. That's formaldehyde. Formaldehyde. And Cr3 plus. Right? We did this one before. This one's +6. Right? We don't need to do that again. Okay, what's happening here? Well, that's a +1. This is a +1, and this is a -2. Right? So that means +3 here, -2 here, +1 there. So we put those together, we get a +2. That means this is a -2. That one carbon is a -2. On this side, we have a -2, and we have a +1. +2, since there are two of them. So this is 0. That means carbon is 0. All right. So, which one is our reduction step? Who gained electrons? Well, it wasn't carbon. Carbon went to 0. Chromium gained electrons. So we have this one, O7 2- yields this one. That's our reduction. Our oxidation then would be methanol going to formaldehyde. All right, so let's take it in order. We got 2 chromiums here, 2 chromiums there, 1 carbon, 1 carbon. We leave the hydrogens and oxygens alone until we balance with water and protons. Electrons. Chromium went from a +6 to a +3. So that means we had to gain electrons, 3 electrons for each chromium, but there are 2 chromiums. So that's 6 electrons. Carbon went from a -2 to a 0. So it lost 2 electrons per carbon, right? Lost 2 electrons. Now we're going to balance the oxygens. We need 7 oxygens on this side. And now we need 14 hydrogens on this side. We have 1 oxygen here and 1 oxygen there, right? So we don't have to balance the oxygens, but we do have to balance the hydrogens. There are 4 hydrogens here and only 2 here. Okay? So we need 2 more hydrogens on this side. Okay, and you add them up. 3 plus 1 is 4. 2 plus 2 is 4. So the hydrogens balance. And the oxygens balance. So everything's balanced except the electrons. Right? So if we need 6 electrons here, we need to multiply this one times 3. 3 there, 3 there, makes that 6, makes this 6. Okay. Now, what was the question? What's the coefficient of water? Well, let's see, where do we have water? We only have water right here. So the coefficient of water is 7. Right? E. All right. Looks like the next one uses the same equation. What's the coefficient of hydrogens? Well, we have 14 hydrogens here. We have 6 here. So those 6 would go away, and that would leave us with 8. Right? So we have 8 hydrogens. I know it's not highlighted, but I thought since it's already on the board, take care of that one. How about these two, 70 and 71? How many electrons are transferred during the reaction? All right, we have gold chloride, AuCl4 with a -1 charge for the whole thing. This is what's known as a complex ion. Plus copper yields gold and chloride. Gold with what? It's neutral. Gold metal, chloride, and Cu2 plus. Okay, so this one's a 0, that one's a -1, that one's a 2 plus, this one's a 0. So what's this one? Well, we have to call this one a -1. So it's a -4 total, hold 1 out, -3, so this is a +3. Okay. How many electrons are transferred? All right. We went from gold 3 plus to gold 0. That means a gain of 3 electrons per gold. Okay. Chlorine doesn't change. Copper does. Copper lost 2 electrons per copper. So if we balance these against 2 and 3, that means we'd have to multiply the gold times 3. Right? Times 3 equals 9 electrons. Excuse me, not 9, 6. 6 electrons. And then if we need 6 here, we got to have 3 there, 3 there. Times 3 equals 6 electrons. Right? So that should be it, 6 electrons. D is the answer. 71. How many electrons are transferred in this reaction? We have 10 plus 2 HCl yields 10 chloride and hydrogen gas. Okay, that's balanced. All right, so this one's 0. This one's 0. That's a -1, -1 plus 1. This is -2 total, so this is a +2. So, which one, what happened to which one? Hydrogen changed, chlorine didn't. So hydrogen went from here to here by gaining 1 electron per hydrogen. And 10 went from here to here. It lost 2 electrons per 10. Right? So in order to balance that, we need 2 of these, which we already have. Equals 2 electrons. Okay? So 2 electrons were transferred. C is the answer. That's messed up. This one right here should be E. Yep, that document's messed up. I'm not sure if the one I handed out is messed up, but this answer sheet is. 75. Okay, in an acid dry cell battery for which the reaction is Zn plus 2 ammonium chloride plus 2 MnO2 yields ZnCl2 plus 2 ammonia plus Mn2O3 plus water. Okay, which is oxidized? Well, let's see. This one's 0. Got any more? No. -2 plus 1. -2, that's a -6 total. That means this one has to be +6 total, which means +3. This one's a +1 plus 3 total. That means -3 for that nitrogen. -1 plus 2. -2 plus 4. -1. And total +4. So a 0, +4, -1, +3, -3. Right? Okay. So which one is oxidized? Which one lost electrons? The zinc went to a 2+. Right? It lost 2 electrons per zinc. Nitrogen didn't change. Hydrogen didn't change. Chlorine didn't change. Manganese changed. It gained an electron from here to here per manganese. Okay, so the one that was oxidized was zinc. A is the answer. Now 75. Let's see. 83. When the equation for the following reaction is in basic solution is balanced, what's the sum of the coefficients? So now we're working in basic solution. We're going to use the fake acid balancing method. H HO2 minus MnO4 minus. Okay, we need an oxidation step and a reduction step because there's oxygen and hydrogen involved. So we got to split them apart. All right, so this one is -2, -4 total, +4. Okay, this one is -2 for oxygen, -4, hold one out. You know, I don't think that's right. Oh, you know what? That is a peroxide. 2 oxygens, 1 hydrogen, and a negative charge. Okay, so this one is -1. If this one is +1, and this one is -1, -2 total, -2 and +1 is minus. Right, so the oxygen is -1. And over here it's -2. So oxygen did play a role. All right. The problem is, well, let's do the oxidation first. This one is -2, -8. We need to hold one out, +7. Okay. So the manganese was oxidized. We can do that. MnO2 yields MnO4 with a minus charge. This one was oxidized, so it's going to have some electrons over here. Okay. And the reduction step is this one. HO2 minus yields something. Right? We don't have anything special up here that we can put over there, but we know that there were some electrons gained in this process. Okay, so we got 1 manganese here, 1 manganese there. We got 2 oxygens here, 4 oxygens there. That means we need 2 more oxygens on this side. Now we need 4 hydrogens over here. How about the electrons? Well, the electrons went from manganese +4 to +7. So it lost 3 electrons. All right. So now we have hydrogen, oxygen. How many oxygens we got here? 2. So we have 2 waters on this side. Okay. And now we have 4 hydrogens. Well, we already got 1 hydrogen here. So we need 3 more hydrogens on this side. That's how we develop this one, where there are no obvious products. Let's see. For this oxygen, we went from -1. We went from, yes, -1 to a -2. So we had to gain 1 electron for each oxygen. Well, we've got 2 oxygens here, 2 oxygens here. We need 2 electrons there in order to balance. 2 minuses went to 4 minuses, so we need 2 more minuses over here. All right, now we need to balance the electrons. We got 3 there and 2 here. So this multiplier is going to be 3 from there. And this multiplier is going to be 2 from there. All right, so we got 2 here, 4 there, 2 there, 6 there, and 8 there. 3 here, and 3 there, 6 there, 9 there, and 6 there. Okay, so what's the sum of the coefficients? All right, let's do some canceling before we bring them down. We've got We only have two MnO2s here, so we can put those down already. Okay, takes care of that. How about on this side? Well, we got these three peroxide ions like that. That takes care of that one. Now, how about the waters? We've got 4 waters on this side and 6 on that side. So these waters go out and leaves us with 2 there. So we're going to have 2 waters on this side. Takes care of that one. And we're also going to have 2 NNO4 minus. Okay, how about electrons? Well, electrons go out anyway. That's the whole purpose. We have 9 hydrogens here and 8 over here. So those go out and leave us with just 1. Okay. Took care of that one, took care of that one, took care of that one. This side, we got this one done. We got waters done. We got nothing left over here. So that's it. Just those 2. Okay. Now, is there anything else? I don't see anything else that'll cancel. That's an even, odd, odd, even, even. So we can't reduce it any further. Let's add them up. 2 plus 3 is 5, plus 1 is 6, plus 2 is 8, plus 2 is 10. So the answer's not there. What did I do wrong? 2 MnO2. How about waters? We have 4 waters here, 6 waters there. All right, so there's two waters. Okay, that's good. 3 HO2 there. Hydrogens. 8 there, 9 here. Let's see. Did I make a mistake there? No, that was right. What about this one? 3 hydrogens. That's 9. Okay, so that should be right. 2 MnO4. Waters had canceled. 2, 2, 2, 4, 5, 6, 7, 8, 9, 10. Okay. I bet I made a mistake down here. So let's see. If we have HO2 minus, and it's going to something, then we need 2 waters on this side. Right? We have 4 hydrogens here, but we already got 1 here, so that means 3 hydrogens. Oh, we're not finished. We're not finished. This is in basic solution. So we have to neutralize this one with a hydroxyl and a hydroxyl. Okay, so that makes 1 water over here and a hydroxyl over there. So this water cancels out and leaves us with 1 there. So let's see, 2, 5, 6, 7, 8, 9. That's the answer, 9. I didn't finish the problem. It's in basic solution. All right. 85 in base, let's see, 85. We got to balance this equation in basic solution. Silver plus copper Cu2 plus. All right. Does it matter whether it's acidic or basic? There's no oxygen there. There's no hydrogen there. We can balance this one without either one. It doesn't matter what the solution conditions are, whether they're acidic or basic. So this one goes from +1 to 0. Right? It has gain 1 electron per silver. Copper goes here, is lost 2 electrons per copper. Right? That means times 1 copper equals 2 electrons. This one needs to be times 2 to equal 2 electrons. So we need a 2 here and a 2 there. And now the sum of the coefficients is 2, 3, 4, 5, 6. C is the answer. And acidic, basic, doesn't matter. That's it.